Okay, so on Wednesday we are going to start class by graphing 2 of our 6 parent graphs just as a review. So make sure they are still practicing these, trying to graph them without looking, because you have a test coming up Friday if you're at school, and then first thing next week, if you don't return until next week, we'll make a time for you to be able to do it. So make sure that you're practicing those parent functions. Also make sure that you're practicing the unit circle, because that test is also Friday, including the definitions that we put in your composition book on the unit circle page, the ones that I showed you in Monday's video. Okay, so we're going to start today with reviewing graphing sine and cosine again, because that's what's going to mostly be on your 4.5 to 4.8 test. There will also be some tangent, maybe some secant, cosecant, which is what we're going to end today with. But it's really important that you can graph the sine and cosine ones, because that's what you're going to see the most. All right, so remember that we need certain information to be able to graph a trig function. So to start with, we need to know the amplitude. So here the amplitude is 4, and remind yourself that it's reflected. The period is the normal period in degrees is 360, and we're going to divide that by 3. So we get, what is that, 120? You have increments, which is going to be that period you just got divided into 4 equal pieces, so 30 degrees. We have a phase shift, which is just what's in parentheses that said equal to 0. Which in this case works out to be 60 if you add the 180 and divide by 3. Then we need to know the vertical displacement, which is just this extra number, so 2, which is the same thing as your midline, just write it as an equation. And then you have a max and a min. To find the max, you do your midline or your vertical displacement plus your amplitude, so 2 plus 4 is 6. And then you subtract them to get your min, so 2 minus 4 is negative 2. All right, so then we draw an x-axis. We start with our phase shift. We count by 30 degrees. And you need to do that 4 times, so make 4 marks, and then count by 30 degrees to label that. So 90, 120, 150, 180. Then you can figure out where your y-axis should go. We said that that's 30, so about 2 of those would be 60. So my y-axis can go back here. Your y-axis is going to get your max, min, and midline. So the middle of our graph is at 2. And we go up 4 to 6, and we go down 4 to negative 2. All right, so when you're graphing a sine function, you normally start your first mark, remember that goes at your phase shift, would be in the middle. And then we normally go up, but since this is a reflected, it's negative, we're going to go down. So my next mark is going to be at my low point of negative 2, then back to the middle point, then up to my high point, then back to my middle point. And then you connect the dots with the sine graph. And you're done. All right, so now that you've seen one more kind of refresher, the next one is in radians. So if you need to watch that one, you watch it. If not, then pause and work it and see how you did. All right, so amplitude is 2. Period normally would be 2 pi in radians, and this one is going to stay 2 pi because there's a 1 there. Your increments, you're going to take that 2 pi and divide by 4, so you get pi over 2. Your phase shift, you're going to take what's in parentheses, equal it to 0, and you get pi over 2. Then we have vertical displacement, and there's an extra number here, so this one's 0, which means your midline is going to be y equals 0. Your max will be 0 plus 2. so 2, and your min will be 0 minus 2, so negative 2. All right, your x-axis, start with your phase shift, add your increments 4 times. So pi over 2 plus pi over 2 is pi, plus another one is 3 pi over 2. So this is 1 over 2, 2 over 2, 3 over 2, so 4 over 2, which is 2 pi, and then 5 over 2. All right, we counted by pi over 2, so we go back, that'll be where 0 is. All right, so we need 0 as the middle, negative 2 as the low, and positive 2 as the high. All right, for a cosine graph, your first mark is up high. So our first mark happens at pi over 2 because our phase shift says we're to move that 0 mark. So it starts at pi, and then we go middle, low, middle, pi. And we draw our cosine graph, remembering that it's going to curve back down on the end. So don't let it look like it's pointing up. All right, last one. We have an amplitude of 1. We have a period. You get to pick whether you want radians or degrees because they don't have either one in this problem. So I'm going to go with degrees because we like those better because they don't make us do fractions. Divide by 4, and we get, what, 90? All right, so for our increments, we're going to take 90 and divide that into 4 equal pieces, and we get like 22.5. All right, what's next? Phase shift. Phase shift is 0 because there's nothing plus or minus in those parentheses. If you set 4x equal to 0 and solve, you just get 0. Vertical displacement is 1 because of this extra guy out front that's being added, which means our midline is at y equals 1. Our max is at 2 because 1 plus 1 is 2. And our min is at 0 because 1 minus 1 is 0. All right, draw our next axis. Start at 0 degrees. You need 4 marks. And we're adding 22.5. Now you can write 22.5 here, or you can know that if I do that twice, I get 45. If I do it twice again, I get 90. And I'm okay if you leave those guys in between blank. But you can also write them in because that's how we normally do it. So what would this one be? 67.5. All right, y-axis obviously goes to 0. And we only need to go, let's see, we need a midline at 1. And we only have to go up to 2 is what I was starting to say, but I forgot to mention my midline. All right, so it's a sine graph. So our first mark is at 0, and it starts in the middle. It would normally be at 0, but we slid up 1, so it goes to 1. And then sine is going to go up, back to the middle, down, back to the middle. And we're going to make a kind of fat little sine graph. All right, so that's our review of graphing sine and cosine. The new thing for today is can we graph the other trig functions. So you should have this paper available to print or just write it on your own paper. That's fine too. I'm trying to grab my composition book. All right. Let's see. All right, so in your composition book, you've already written like what sine and cosine look like. And then we're going to make a pocket to put our paper in. Yeah, so hold on. Okay, we put sine and cosine in the other day. We made a pocket to put our sine and cosine information in. And then we can put our cosine information in there. All right, so we labeled 4, 5, and we got our sine and cosine basic graphs in there. And then we made a pocket, so that takes 2 pages. I need to go back and do this because I haven't done it yet. And then on the back of this page, so we fold this down. Y'all bear with me. Fold this down, glue it to make a pocket. And then on the back of your pocket that we have made, we're going to start section 4.5. No, 4.6, my fault. Which is graphs of other trig functions. So 4.5 was on sine and cosine. This is on the others. And we're going to make ourselves, just like we did with sine and cosine, we're going to make ourselves, this is what tangent looks like, this is what secant looks like, this is what cosecant looks like, this is what cotangent looks like. Alright, so for tangent. The period of tangent is 180, so we only have to go out to 180. So then we have a 90, and then we have, if we want to split it into quarters so that everything is the same, then we have a 45 and we have a 135. And you can mark your 1 and your negative 1 on your y. Alright, so remember tangent was 0 at 0, 1 at 45, asymptote at 90, negative 1 at 135, 0 at 180. And it made like a swoosh up this way, and you know this goes this way, and this went down like this, and this one's going to go up like that. Alright, so when I ask you to graph tangent, that's all I need from you, is that little bit. Okay, so then if I do a, we'll go ahead and do a cotangent, which I honestly don't know if you're ever asked to graph a cotangent. We're not doing one in our notes, but it may happen in your assignment. Alright, so this one's going to be marked the same way because tangent and cotangent have the same period. Alright, but cotangent, remember, has an asymptote at 0 and an asymptote at 180. So it's 0 at 90, it's 1 at 45, just like tangent, and negative 1 at 135. But you draw like the opposite picture. When you graph cotangent, you're just going to get one little squiggle. Alright, so if we are going to graph a secant, or a cosecant, what do I want to do? We'll do a cosecant. Alright, we need a 1, we need a negative 1. It has a period of 360. So we'll mark it just like we do sine and cosine. Alright, so cosecant is the reciprocal of sine. So that means that it has asymptotes where sine is 0. So at 0 and 180. So we have asymptotes here, here, and here. We know that at 90 it's 1 because sine is, and that's all I need you to know, is that it's 1 at 90, negative 1 at 270, and that it makes a U in both of those spots. Alright, so then your secant is going to be pretty similar to that. So set everybody up the same way. Alright, and then you can't see that. This one has asymptotes at 90 and 270. And it is 1 at 0, negative 1 at 180, and 1 at 360. And you know that you get like a piece of a U, a whole U, and a piece of a U. If you are thoroughly confused about where I'm getting this, that means you have not been studying your parent functions, and you should get on that because that test is coming up real soon. Okay, so now back to our worksheet. How do we take this information and graph from there? Alright, so we're going to find info basically all the same way. So technically, if you have there is a cotangent on here. There's one of each. Good job for me. If we have the cotangent, tangent, secant, cosecant. All of those go on forever up and down. So there isn't really an amplitude. So we don't call it amplitude, but we still need to understand that that number is there, and it works kind of the same way. We're still stretching those 1 and -1 points to a new place. So in this case, they're going to stay the same because this one has an amplitude of 1, but not really. All right, period works the same way. Normal period is 360 for, no it's not, we're doing cotangent, my fault. Cotangent, normal period is 180. Divide that by this number. So we get 180 divided by 4 is 45. I want to make sure I don't confuse you, so anytime I'm not 100% sure, we're going to use our calculator real fast. All right, so split that into 4 equal pieces. Divide that by 4. We get 11.25. All right, phase shift. Set your parentheses equal to 0. And I believe you get 22.5. All right, vertical displacement is 3. So our midline is y equals 3. Our maximum, which is not really a maximum, is going to be 3 plus 1 is 4. And our minimum, again, not really a minimum, is 3 minus 1 is 2. All right, so draw your x-axis. We have a phase shift of 22.5. And we need 4 more marks. And again, you're counting by weird little decimals. I don't need you to write every one of them. This is plus 11.25 plus another 11.25 means we can just add 22.5 again and be at 45. Plus 11.25 plus 11.25. So you can just mark every other one if they're gross little decimals. All right, so we need to go about this far back for the y-axis if we want to be accurate about where we put it. But again, I'm not that picky. All right, so on the y-axis, we need a midline of 3, a low point of 2. I just put 2 at 1. I didn't realize that. And a high point of 4. All right, so all of those points that happened at 0 are now going to happen at 3. Okay, so for a cotangent graph, you have, if you look back, you have asymptotes at the beginning and the end. So this is an asymptote because we shifted, and this is an asymptote because we've shrunk it. All right, so for cotangent, the middle is 0, and then this side is up and this side is down, and then you draw your little cotangent curve. All right, so you see how we have the same picture? It's just the numbers are different. And that's pretty much how it's always going to be. All right, so secant. Again, there's not really an amplitude. And if you see this, like amplitude is from the middle to the high point. Well, there is no high point, but we did keep it just 1 away for those points. And then there's no max or min because they go on forever. But the points that we put on our graph is what we're really talking about. All right, so amplitude would be 1, so not really. Period, the normal period is 2 pi. If they are dividing by 2, you're going to times 2, so we get a new period of 4 pi. If we divide that by 4, we have increments of pi. Our phase shift, we're going to take x over 2 plus pi over 2 equal it to 0. So x over 2 equals negative pi over 2. Again, multiply that at 2. So you just get negative pi. All right, so then next we have vertical displacement, which in this case I put it on the back, so it's 2. So midline is y equals 2. Your max is 2 plus 1 is 3. Your min is 2 minus 1 is 1. So remember, those really aren't maxes and mins. They're just where we're going to put some points. All right, x-axis. Phase shift says start at negative pi. You need 1, 2, 3, 4 more marks. We're going to add pi, so this is 0, pi, 2 pi, 3 pi. Put your y-axis through 0. We need 1, 2, 3. Your midline is at 2. Alright, so now we're doing secant. And remember, if you look back at what we put in our composition book, secant has asymptotes at 90 and 270. So the second and the fourth spot. So we have an asymptote at the second and the fourth spot. We are going to have a U that goes down in the middle, and then ones on the outside that go up, and we know where to put those points based on these max and mins. So we have a point at 30 on those outside points, and a point at 1 on those inside points. We're going to make a U that points up here and here, and that points down here and here. Alright, so for tangent, remember that the amplitude isn't really there. This one will be 1, and remind yourself that we're reflected. Period is normally 180. We're going to divide that by 3, so we're 60. Increments, you divide by 4, and you get 15. Phase shift, set what's in parentheses equal to 0, and you get 40. Vertical displacement is 1, so the midline is 1, the max is 2, and the min is 0. Remember, max and min are not really a max and a min, and to get them you do vertical displacement plus your amplitude. Okay, so on our x-axis, we start at 40. I'm going to speed it over a little bit because I'm counting by 15s, and I won't worry to put my y-axis. Alright, so 1, 2, 3, 4 more. We're adding 15, adding 15, adding 15, adding 15, which is literally not 90, it's 100. Alright, so I do 40 plus 60, I get 100, I know that I'm right. Alright, so I'm going to go back roughly here, and again, I'm not looking for perfection. Alright, so we're doing tangent, and tangent has an asymptote right smack in the middle. And we get a piece that goes this way and a piece that goes this way. Except that we are reflected, so we're actually going to go down and up. Alright, so again, normally tangent is, the first mark is at 0. And then we would go from there up, but this one we're going to go down. So this is going to go like this, and that means this side would have to go up. Alright, then normally this one would be 0 here, and we'd be negative, or we'd go down, but since we're reflected, we're going to go up. So it looks like this, and we know this is going to go like this. Alright, so last one, again, not really an amplitude, but it's 1. Period is normally 2 pi for cosecant, and we're going to divide by 2, so it's just pi. You divide that into 4 equal pieces, you get pi over 4. You take what's in parentheses, set it equal to 0. When you divide by 2, it's like timesing 1/2. So you get theta, and over here you get 30 pi over 4. So that's our phase shift. Vertical displacement is 1, so midline is 1. Max is 2, min is 0. Those aren't really a max and a min. Alright, so phase shift. We're going to start at 3 pi over 4. Make 1, 2, 3, 4 more marks. And we're going to add pi over 4. So 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4 are reduced here and here. Alright, and then we're going to back up and put our y-axis. And you need 0, 1, and 2 labeled. The middle is moving up to 1. Alright, so cosecant is going to have asymptotes at the beginning, middle, and end. We have a u that goes up and a u that goes down. And since we're positive, we get to do that. So we put a point at the high point and draw a u that goes up. And then we put a point at our low point and draw a u that goes down. Alright, I know that was kind of fast. Go back and watch it again if you need to. If you have specific questions about how do you find this, or does my graph look okay, then please email me. We will do a few more tangents tomorrow because that's what's most likely on your test. I'll go over the homework and answer questions. So since you're not going to be here for that, make sure that you send me your homework so I can give you feedback and you ask any questions that you have.